Section 2.3, lines. In this section, we're going to talk about lines in general. So the first thing we need to know is what the slope of a line is. Slope is also known as rate of change. Okay, so as you can see here, we know that slope is rise over run. Okay, rise over run. How much the line rises versus how much the line runs, so going from left to right. The rise is represented by your change in y values, and the run is represented by your change in x values. So that leaves us with the formula m, which stands for slope, m is slope, is equal to y2 minus y1 divided by x2 minus x1, the difference in the y's divided by the difference in the x's. And so we're going to be given two ordered pairs. Okay, we'll call the first ordered pair x1 comma y1, and we'll call the second ordered pair x2 comma y2. So we'll label them as ordered pair 1 and ordered pair 2 to use them in this slope formula. So let's talk about the different types of slope that we could have. All right, first we have one that rises from left to right, one that rises from left to right. All right, that is going to be a positive slope. All right, so this first one is a positive slope. Then we have one that falls from left to right. That one's going to be a line with a negative slope. Okay, this third one here is a vertical line. All right, a vertical line has an undefined slope. Undefined slope. Why? Well, if we think about it in terms of rise over run, okay, so if I pick 2 points on this line, let me see if I can get them. There we go. If I pick 2 points on this line, how much do I rise to get from one point to the next? Well, it depends on the 2 points I pick. So the rise is some value, okay? So some value. And the run, going from left to right, from this first point to the second point, is 0. I don't move left or right. So whenever I take a number and I divide by 0, that's always going to give me undefined, okay? Now, one more thing to add to this, just for future reference, and we'll see this later on, when you have a vertical line, it has a special type of equation. The equation of a vertical line is always x equals a number. So it's always x equals whatever x value that line is crossing through. Okay? So then we move on to the last one, which is a horizontal line. Okay? So a horizontal line doesn't have an undefined slope, it has a 0 slope. Now let's talk about why. Again, if I pick 2 points on this line, I think about it in terms of rise over run. How much am I rising? 0. And how much am I running? Well, some number. Okay, some number of spaces. 0 divided by a number is always 0. Okay, so whenever I have a horizontal line, my slope is going to be 0. Now, just like we had for the vertical line, we have a special equation of any horizontal line. A horizontal line is always y equals a number, and that number depends on which y value that line is crossing through. So again, we have positive slope, negative slope, an undefined slope for vertical lines, and a 0 slope for horizontal lines. Make sure you don't get those two mixed up. They're very easy to kind of confuse. Example 1, find the slope without graphing. Then state whether the line is rising, falling, horizontal, or vertical. They give us two ordered pairs. They give us the ordered pair 3, -2, and the ordered pair -4, -5. So remember, I just want to label these. It doesn't matter which ordered pair you use first. I'm going to start with 3, -2 just because it came first. So 3, -2. I'm going to call that my x1, my first x, and my y1, my first y. And then my other point, -4, -5, I'm going to call that x2 and y2. Okay, remember the slope formula is m is equal to y2 minus y1 divided by x2 minus x1. So now that we have them labeled, we can easily plug them in. My y2 is negative 5, so negative 5 minus my y1. So be careful, minus my y1 is negative 2, so minus a negative 2. And my x's, x2 is negative 4 minus x1, which is 3. So if I look at the top, negative 5 minus a negative 2, I know that negative 5 minus a negative 2 really means plus 2. All right, and then on the bottom I have just negative 4 minus 3. That doesn't change. So on the top, negative 5 plus 2 is going to leave me with a negative 3. On the bottom, in the denominator, I have negative 4 minus 3, which is a negative 7. Okay, but we're not done yet. We have a negative divided by a negative, and I know that that is a positive. So my slope between these 2 points is 3/7. Okay, so I found the slope. It now says, then state whether the line is rising, falling, horizontal, or vertical. Well, since we have a positive slope, we know that our line is rising. Example 2. Here we have another slope problem. It's exactly like the last one. So we're going to find the slope without graphing, and then we're going to state whether the line is rising, falling, horizontal, or vertical. So I'm given 2 ordered pairs again. My first ordered pair is negative 3, 7. And remember, I want to label that my x1 and my y1, my first x, my first y. My second ordered pair is negative 3, negative 4. So I'm going to go ahead and label that my x2 and my y2. Once I have them labeled, remember, I'm going to plug them into my slope formula. So slope, which is m, is equal to my y2, so negative 4, minus my y1, so minus 7, divided by my x2, which is negative 3, minus my x1, which is also negative 3. So negative 4 minus 7 gives me negative 11. And we know that negative 3 minus another negative 3 is going to be the same as negative 3 plus 3, which I know is 0. So I have negative 11 divided by 0. We have to make a decision at this point. We can't leave our slope like that. Okay, we know when there's 0 that we're either going to have an undefined slope or a 0 slope. Well, when 0 shows up in the denominator, that makes our slope undefined. So we have an undefined slope. Okay, now it says state whether the line is rising, falling, horizontal, or vertical. If the slope is undefined, that is a vertical line. Now that we know how to find the slope of a line, we're going to focus in on the slope-intercept form of a line. So we're going to start writing equations of lines. Okay? So slope-intercept form is y equals mx plus b. Now, we got to figure out what these stand for. Well, we just talked about what the m stood for. Remember, m is your slope. And we have the slope formula. So if we don't have the slope, we can always find it. Then we have b. B is your y-intercept. Okay, so we have 2 key pieces. We have slope and y-intercept. Y equals mx plus b. That's the form of the equation that we're going to write all of our lines in. Okay, all lines are going to be in y equals mx plus b form. Now that we're familiar with what slope-intercept form looks like, which is y equals mx plus b, now we need to come up with some steps for turning some information into an equation of the form y equals mx plus b. So the first step is we know we're going to need an m and a b. Eventually, that's what we're going to need to write our equation. So the first step is always find the slope if it's not already given. Some problems, they will give you the slope. Sometimes they'll give you 2 ordered pairs, and we have to use the slope formula to find the slope. Once we have the slope, then we're going to plug in our x value and our y value and our m into y equals mx plus b. Okay, so let's recall the x and the y right here are going to be the ordered pair that they give you. Okay, so you're going to have an ordered pair. Then we know that m is the slope. So we're going to plug in an ordered pair of an x value, a y value, and the slope. That means that b is going to be a variable. So I'm going to have to solve for b. Okay, so then finally I'm going to write my answer in y equals mx plus b form. So I'm going to have some value for m, and I'm going to have some value for b, and my answer is going to have those values in it. So it's going to be, let's say m is 2 and b is 4. My final answer would be y equals 2x plus 4. So your final equation, in your final equation, x and y should be variables, and your m and b should have values. Example 3. Find the equation of the line in slope-intercept form, then graph. So let's look at the information they've given us. They've given us an ordered pair, okay, and they've given us the slope. So again, let's think about what we're going to need. Eventually, to write an equation in the form y equals mx plus b, we're going to need the slope and we're going to need the b, okay, the y-intercept. So we're going to have to fill in the slope and we're going to have to fill in the y-intercept. So right now we have the slope, which is awesome, but we do not have the y-intercept. So we have to figure that out. But we do have an ordered pair. We have an x value and a y value. So we can use that information and plug it in. So we have step 1 is done. We have the slope. We're moving on to step 2. So it says we're going to use y equals mx plus b. Step 2 tells us to plug in values for x, y, and b. So that's going to give me negative 2 equals 2/5 times 10 plus b. Okay, again, we're still on step 2. It says once you've plugged those in, you're going to go ahead and solve for b. So negative 2 equals 2/5 times 10 is 4. And then we have plus b. And we're still solving for b. So I'm going to subtract 4 from both sides. And that's going to give me b equals negative 6. Okay, so now I have a value for m and I have a value for b, so I can write my equation. So my equation is y equals 2/5 x minus 6. Y equals mx plus b. Remember, I'm always filling in the m and I'm filling in the b. Now let's take a minute and graph this. Okay, when you're graphing an equation, slope-intercept form is perfect. Okay, we know the y-intercept, and we know that the y-intercept is where the graph crosses the y-axis. So this line is going to cross the y-axis at negative 6. So I'm going to start with putting a point down on the y-axis at negative 6. Maybe. Let's see if I can get it to work. All right, there we go. And then it says that the slope is 2/5. So from that starting point, from negative 6, I'm going to rise 2, and I'm going to run 5. All right? When it's positive, remember we're rising from left to right. So I'm going to go up 2 and then to the right 5 and put my new point. Whoop, not perfect. Not good with this. Sorry, guys. All right? So you're going to plot the point, negative 6. And then when you rise 2 and you run 5, we're now at the point 5, negative 4. The last step is to go ahead and connect those values. Mine is going to be terrible because I'm bad with this pen. Okay? But we just need to connect those 2 points to see the graph of that line. Example 4. Write the equation of the line passing through the points negative 5, 1, and 2, 7 in slope-intercept form. So again, we know slope-intercept form is going to be y equals mx plus b. Okay, and so we're going to follow our steps. Step 1 says if the slope is not given, then we need to find the slope. So what I'm going to do is I'm going to label this first point, negative 5, 1, as my x1 and my y1. And I'm going to label this second point as my x2 and my y2. Then I'm going to find the slope. Slope formula is m equals my y2, which is 7, minus my y1, divided by my x2, which is 2, minus my x1, so minus -5. And let's go ahead and simplify that. 7 minus 1 is 6, and 2 minus a -5 we know means plus, so 2 plus 5 is 7. Okay, so that again is step 1. Step 2 says, all right, now that I have my slope, I can go ahead and plug it into y equals mx plus b using my slope and either of the points. If they give you 2 points in the problem, you pick your favorite one. I prefer to use the point 2, 7 just because I don't like to deal with negatives. So I'm going to use 2, 7 as my point, and obviously my slope is 6/7. So I'm going to plug those into y equals mx plus b. My y value is 7. My slope is 6/7, and my x value is 2. And I know that b is a variable that I need to solve for. So that's going to give me 7 equals 6/7 times 2 gives me 12/7. And then I have plus b. All right, my next step is going to be to subtract 12/7 from both sides. So I'm going to go ahead and subtract 12/7 from both sides. And you should have your calculator out, so you can go ahead and do 7 minus 12/7 in your calculator. Okay, and you should get that b is equal to 37/7. Leave it as a fraction, no decimals here. Okay, and then step 3. Step 3 tells us to take all that information and plug it in. So we have the important parts. We have m is 6/7, and we have b is 37/7. And we need to plug it into y equals mx plus b. Okay, so my final equation is y equals 6/7 x plus 37/7. Don't be scared of fractions. It's okay. For example 5, we're going to write the equation of a vertical line passing through the point -4, 5. Okay, so let's recall. Let's think about first what a vertical line is going to look like. All right, here's my grid. It's passing through the point -4, 5. So -4, 1, 2, 3, 4, and then +5, 1, 2, 3, 4, 5. So it's passing through this point -4, 5. And it's a vertical line, so here's my vertical line passing through that point. Okay? We need to write the equation of that line. So if you recall, if you go back to your notes at the beginning, we talked about the different types of slope. And specifically, we talked about vertical lines and horizontal lines. Vertical lines and horizontal lines have special equations, okay? So let's look at this vertical line. This vertical line is cutting right through the x-axis. So if you recall, a vertical line is always going to have an equation, x equals some number. And that number is whatever x value it's going through. So the equation of this vertical line is simply x equals -4. All right, this one's the easy one. You just need to know the difference between vertical line equations and horizontal line equations. You're going to see that example 6 looks very similar to example 5, but this time it's asking us to write the equation of a horizontal line passing through that point -4, 5. So again, let's look at what that's going to look like. 1, 2, 3, 4, and 1, 2, 3, 4, 5. So here's my point, -4, 5. This time I have a horizontal line passing through that point. Okay? So similar to when we did the vertical line, look at this line. It's cutting through the y-axis. So that should indicate to us that my equation is going to be y equals something. Well, what y value am I passing through? I'm passing through 5. So the equation of my line is simply y equals 5. Example 7. Write the equation of a line that has an x-intercept equal to -5 and y-intercept equal to -2 in slope-intercept form. So I know that my final answer needs to be in slope-intercept form, which is y equals mx plus b. So let's talk about what information is given in this problem. All right, refresher of x-intercept. An x-intercept is where the graph crosses the x-axis. And so we need to take that information, which we know the x-intercept is -5, and we want to write that as an ordered pair. So that really gives us the ordered pair -5, 0. Okay? Now, the y-intercept is -2. So just like we did with the x-intercept, we want to write that as an ordered pair. That is the ordered pair 0, -2. Okay? So if you go back, I believe it was example 4, when we were writing the equation of a line given 2 points, this is very similar, but we have a little shortcut. Okay? So let's refer back to our steps. Step 1 was to find the slope. Okay? So slope is equal to y2 minus y1 over x2 minus x1. Let's go ahead and label our points. Let's call this x1, y1, and let's call this x2, y2. So that's going to give me m equals -2 minus 0 divided by 0 minus -5. Okay, so -2 minus 0 is -2, and 0 minus a -5 is going to give me +5. Okay? Step 2 is to solve for b. Well, we are given b. Remember that b is the y-intercept. They give us the y-intercept in this problem. They're telling us the y-intercept is -2, so I don't have to do any work to know that b is equal to -2. Okay? Now remember, once I have my slope and once I have my y-intercept, I can go ahead and write my equation. So my equation is going to be y equals -2/5 x minus 2. I plug in my m and I plug in my b, and I have my equation. Now we're going to move on and talk about a relationship between lines. Okay? Two lines can be parallel if they have the same slope. So parallel lines, we know, are never going to intersect. Okay? So could be something like that. We have parallel lines, never going to intersect. Again, they're going to have the same slope. Okay? Here's another set of parallel lines. All right? So let's look at the equation of two lines. Y equals 2x minus 4 and y equals 2x plus 3. These are two different lines, but if you notice, they have the same slope. They both have a slope of 2. So these two lines would be parallel. That is the only way for two lines to be parallel, is if they have the same slope. Now let's talk about our two oddballs, our vertical lines and horizontal lines. All vertical lines are parallel. Well, I'm stating that because we know that a vertical line has an undefined slope. Okay, so it's not a numerical value, but I know that all vertical lines have an undefined slope, so they are all going to be parallel to each other. Okay, I also know that all horizontal lines have the same slope. They all have a slope of 0, so they're also all going to be parallel. All right, and then perpendicular lines, that's our second relationship. Perpendicular lines are going to have opposite reciprocal slopes. Now, here's probably what you're thinking. Perpendicular means they make a right angle. Well, that doesn't mean you have to have a vertical and a horizontal line. Okay, we could have diagonal lines that form a right angle. Okay, so again, perpendicular lines, two lines that intersect to form a right angle, are going to have opposite reciprocal slopes. So let's talk about what that means. Let's say I have the equation y equals 2/3 x plus 3. That's the equation of my line. A perpendicular line, again, would have an opposite reciprocal slope. So it would have y equals, opposite means opposite sign, Reciprocal means flip, so it would be negative 3/2 x. And it could be, I don't know, plus 1. Okay, they don't have to have the same y-intercept. We're only looking at the slope. Okay, if the slopes are opposite reciprocals, then the two lines are perpendicular. Okay, and we know that a vertical line and a horizontal line are always perpendicular to each other. So let's write that. A vertical line is always perpendicular to a horizontal line. Okay, so these are our two cases. We have lines that are parallel, lines that are perpendicular, and if they're not parallel and they're not perpendicular, then we just simply say that they are neither. Example 8, determine whether the pair of lines is parallel, perpendicular, or neither. Okay, so if you recall back to our last slide, we know that two lines are parallel if they have the same slope. So they're going to be parallel if they have the same slope. And they're going to be perpendicular if they have opposite reciprocal slopes. Okay, if we don't have the same slope or the opposite reciprocal slope, we know that these two lines are going to be neither. So first, we need to get them into a form where we recognize the slope, okay? So I'm going to look at the second equation first. This second equation, y equals negative 4x plus 1, is already in a form that I recognize. I know that the slope of this line is negative 4, okay? But when I look at this other line, I have x equals 4y plus 8, I can't look at that and pull out the slope. I don't know what the slope is when it's in that form. So what I need to do is I need to rewrite it into slope-intercept form. Okay, y equals mx plus b. So to do that, I'm going to solve for y. Okay, so I'm going to do minus 8. So that gives me x minus 8 is equal to 4y. And then to get y by itself, I'm going to divide every term by 4. Okay, so I'm going to write this x over 4 as 1/4 x. Okay, you could still write it as x over 4, but I like to have that coefficient out in front. Minus 8 divided by 4 is 2 is equal to, our 4's cancel out, and we have y. So let me write it in an organized fashion. I'm going to put my y on the left-hand side. Y equals 1/4 x minus 2. Okay? Just so I have it in slope-intercept form. So I know the slope of this line is 1/4. So let's look at my two slopes. I have m equals negative 4, and I have m equals 1/4. I see that they're not the same, so they're definitely not parallel, but they are opposite reciprocals. And remember, opposite means opposite sign. We have one negative, one positive. And this 4 right here we know is really 4 over 1. So when we flip that, we find the reciprocal, that is 1/4. So these two lines are perpendicular. Example 9. Write the equation of the line in slope-intercept form that is parallel to x equals 5 and passes through the point 4, 7. So over on the side, I'm going to kind of just draw out a little sketch of what this is telling me, what information they're giving me. Okay? So they're telling me I'm passing through the point 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So I'm passing through the point 4, 7. And I am parallel to the line x equals 5. Okay, parallel to the line x equals 5. Well, I know that x equals 5 is a vertical line. Okay, x equals 5 is the vertical line that passes through the x value of 5. Okay, so I have this vertical line passing through 5, and I want to write an equation of a line that is parallel to that and is passing through this point 4, 7, this new point we have here. Well, in order for it to be parallel, it has to be the same slope. So we know that if we have a vertical line already, in order for it to be parallel, it also has to be a vertical line. So I'm really looking for the equation of a vertical line that passes through the point 4, 7. I know that every equation of a vertical line is going to be x equals, and the value is whatever x value it's crossing through. So we're crossing through the ordered pair 4, 7, so my equation is simply x equals 4. Okay, and that would be this line right here that's crossing through the point 4, 7, and is parallel to that line x equals 5. Example 10. Write the equation of the line in slope-intercept form that is perpendicular to y equals -4 and passes through the point -3, -5. So again, I like to just do a little sketch of the scenario that's going on. Right now, they're giving me the equation y equals -4. Okay? Y equals -4, I know, is a horizontal line crossing through -4. So this is a horizontal line. Whoop. Okay? If I want to be perpendicular to a horizontal line, then my answer must be a vertical line. Okay, I need a vertical line. So to find my answer, find the solution to this problem, I want a vertical line that's passing through the point -3, -5. Okay, so remember a vertical line through the point -3, -5, -3, 1, 2, 3, 4, -5. So we want to cross through this point right here. Okay, a vertical line is going to cut straight through the x-axis. So I know the equation of a vertical line is always x equals whatever x value we're cutting through. So the answer to this problem is x equals -3. Example 11. Write the equation of the line in slope-intercept form that is parallel to 12x minus 2y equals -10 and passes through 2, 3. Well, notice in this example, we're not talking about vertical and horizontal lines, so we have to do a little bit more work. Okay? So first, remember that we want to write our equation in the form y equals mx plus b. All right? We're going to need to figure out what slope we're going to use and what the b is going to be. Okay? We need those two pieces of information to write our final equation. So they tell us in the problem that we are parallel to this line. We are parallel to 12x minus 2y equals -10. If I'm parallel to that line, that means that I have the same slope as that line. Well, when I look at this equation in this form, I can't look at it and tell what the slope is. I need to rearrange it, get it into slope-intercept form so that I can figure out what the slope of this line is. So to do that, I'm going to go ahead and get the y by itself, isolate the y. So I'm going to do minus 12x. That's going to give me, make sure you don't lose this negative, -2y equals -10 minus 12x. All right, again, I'm trying to isolate the y, so I'm going to divide all of the terms by -2. And that's going to give me y equals -10 divided by -2 is a positive 5. -12x divided by -2 is a positive 6x. And then in my last step, I'm just going to rewrite it with the 6x first so that it's in y equals mx plus b form. Okay, so notice the only thing I need from this equation is the slope. Okay, so I'm going to use m equals 6 because it says it's parallel to that line. That means the line that I'm writing the equation for has to have that same slope. So back over here, basically they've given me the information that I want the slope to be 6 and I want to pass through the ordered pair 2, 3. So we go back to what we did at the beginning of this unit, and we're writing the equation in slope-intercept form, y equals mx plus b. So step 1, remember, was to find the slope, which we now have. Step 2 tells us to plug our point in and our m and solve for b. So that's going to give me y, which is 3, equals 6 times the x, which is 2, plus b. So 3 equals 12 plus b. All right, and I need to solve for b, so I'm going to subtract 12 from both sides. So that's going to leave me with b equals -9. Okay, so my final answer, I have the slope that I want, and I have my b, my y-intercept. So my equation is y equals 6x minus 9. Example 12. Again, we're going to write the equation of the line in slope-intercept form. This time, that is perpendicular to the equation -2x plus y equals 14, and it passes through the point 0, 0. Okay? So again, recall, if we're perpendicular to this line, then I need to first figure out the slope of this line. So I'm going to go over here. I have -2x plus y equals 14. I need to figure out what the slope of this line is. Well, again, in this form, I don't know what the slope is. So I'm going to isolate the y, get the y by itself. To do that, I'm going to add 2x to both sides. So it gives me y equals 14 plus 2x. And then I'm going to rewrite it in the order that I like, which is y equals 2x plus 14. Okay, y equals mx plus b. The slope of this line is 2. But if I want to be perpendicular to that line, I'm not going to use 2. I'm going to use the slope m equals the opposite reciprocal of that. Okay? So opposite means opposite sign, so negative. This was a 2 over 1. So if I find the reciprocal of that or flip it, I'm really want to use -1/2. Okay? So I'm really finding the line that has a slope of -1/2 and passes through the point 0, 0. Okay? So y equals mx plus b. Let's plug in what we know. My y is 0. My m is -1/2. My x is 0 also. And then I have plus b. I need to solve for b. 0 equals -1/2 times 0 is 0 plus b. So that gives me b equals 0. So I have my m, I have my b, so I can write my equation. So my equation is going to be y equals -1/2 x. Okay? You could write the plus 0 if you wanted, y equals -1/2 x plus 0, but plus 0 isn't necessary. So we can keep it simply as y equals -1/2 x.